This video is for your notes on sequences, or SOL 6.17. It goes through pages 103 through 106 in your notebook. You'll need a pencil to complete these notes. A set of numbers arranged in a special order. So in this pattern, we see that going from the first number to the second number, we add 2. And so 1 plus 2 is 3, 3 plus 2 is 5. 5 plus 2 is 7, and 7 plus 2 is 9, and 9 plus 2 more would get the last number in this pattern, or 11. To get from 4 to 8, we could add 4 more to get 12. 12 plus 4 would be 16, plus 4 more would give you 20, and plus 4 more we could get 24. And we keep on adding 4 in that pattern. This last pattern, we see that we would double each term or multiply each number by 2 to get the next number. So 2 times 2 is 4, times 2 more is 8, times 2 more is 16, times 2 more is 32, times 2 more is 64. This is called a sequence. Now there's a typo in this next one, so I want you to change the 15 to a 16. So change that 5 into a 6 before we start. A type of sequence that has a common difference. So if you take any two numbers that are next to each other in a sequence, let's say 1 and 4 in this top sequence, the difference is always going to be the same. So the difference between 1 and 4 is 3. The difference between 13 and 16 is 3. So in this next one, the difference between 29 and 24 is 5, and the difference between 14 and 9 is 5. So the difference all the way through is the same. Then we know that it's an arithmetic sequence. Now you've seen this word before, but you've seen it in a different context, and then it's pronounced arithmetic. But when it's being used as a noun, we say arithmetic. We have a rule, and when we have a common difference, that means that we're going to be adding or subtracting for our rule in an arithmetic sequence. Now, a type of sequence that has a common ratio. Now, ratios can be written as fractions. So keep that in mind. We're going to have some fractions as part of our rules because our rule can only be with multiplication when we're looking for that common ratio. So moving from 1 to 2, 2 to 4, 4 to 8, 8 to 16, we are multiplying by 2 to get from one number to the next. So my rule is to multiply by 2, and my common ratio here would be 2. If we're going the opposite way, we're actually multiplying by 1/2 because we're taking half of this. So you might see this as dividing by 2, but multiplying by 1/2 and dividing by 2 are the same thing. We need to only think of this as multiplication in this situation. And this is called a geometric sequence. Now, to be able to distinguish between an arithmetic and a geometric, A comes before G in the alphabet, and you learn addition and subtraction before you learn multiplication. And that's how I tell the difference. A type of sequence that is made by adding two terms to get the next term. So 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 5 is 8, 8 plus 13 is 21, 13 plus 21 is 34. So you take two terms and add them together, and then you get the third term. This is a special type of sequence called the Fibonacci sequence, and it was named for an Italian mathematician who made it famous. The name of each individual number in a sequence. So 3 is the first number or the first term of that sequence. The second number or second term is 5. 7 is the third term of that sequence, and 9 would be the fourth term of that sequence. So term is the word used to refer to each number in a sequence. The amount that's being added or subtracted from each term in a sequence to find the next term. So in the sequence of 2, 4, 6, 8, we see 4 minus 2 is 2, and 6 minus 4 is 2, and 8 minus 6 is 2. We just found the difference between all of those terms. So we just found all of the differences, but all of the differences that we found, or the answers to a subtraction problem, weren't the same. They all had that difference in common. So we call this a common difference. And this would be an example of an arithmetic sequence. So the amount that each term in the sequence is being multiplied by to find the next term, we can look at 256, and if we take half of it, we get 128. And you might look at this as dividing by 2, but multiplying by 1/2 and dividing by 2 are basically the same operation. And here we see that multiplying by 1/2 goes all the way through the sequence. So 1/2 is going to be our common ratio. When we think of an arithmetic sequence, we need to be thinking about addition and subtraction. And we're going to take that addition and subtraction, and that same number being added or subtracted is going to go all the way through the sequence. Geometric, we need to think about multiplication going all the way through the sequence, and it needs to be multiplied by the same number. From 2 to 4, we know that this is increasing, so we know it's going to be either addition or multiplication. And when I look at this, I see that 2 plus 2 would be 4, but 2 times 2 would be 4 as well. So we want to see what works all the way through. 4 times another 2 is not going to give us 6, so we know multiplication doesn't work. But addition does work again, and 4 plus 2 is 6, 6 plus 2 is 8. So the rule here is that we're adding 2 all the way through this pattern. And if we're adding 2 and our rule is addition, we're going to have an arithmetic sequence. And we're going to keep adding 2, and 8 plus 2 is 10. 10 plus another 2 is 12. So my rule of adding 2 went all the way through. So if it's the same number all the way through, then it's an arithmetic sequence. This next one is getting bigger, so I want to try addition and multiplication. If I try addition, I'm going to be adding 6, and if I'm doing multiplication, I'd be multiplying by 2. So let's see what I would need to add. I would have to add 12 plus 12 to get 24, or I could just double it or multiply by 2. We're not going to use the addition because the multiplication is a little bit more consistent. So 24 times 2 is 48, and 48 times 2, well, 2 times 8 is 16, carry the 1, 4 times 2 is 8, plus 1 is 9, and we get 96 for that 1, 2, 3, 4, 5th term. So my rule is multiplying by 2. So when I multiply by the same number all the way through, that is a geometric sequence. For this next pattern, I'm going to see that it gets bigger, but I'm going to add 0, then I'm going to add 1, and 2 plus 1 is 3, 3 plus 2 is 5, and that's not the same number all the way through. So this is not going to be an arithmetic sequence. Even though it's addition, it's not an arithmetic sequence. This is going to be neither arithmetic nor is it geometric. This is actually called the Fibonacci sequence. And this is where you see the 1, 1, 2 that we're adding are the first 3 terms of the sequence. So the 1, the 2, the next thing I'll add is the 3. So 5 plus 3 is 8. And then the next term is 5, so that's the next thing that I'm going to add. And 8 plus 5 is 13. So this keeps on going, and the next one that I would be adding is 8. So the rule here is that I add 2 terms to get the next one. All right, and that's a very messy rule. That's why it's neither arithmetic or geometric. This next one is increasing. So I see 10 times 2 is 20, or 10 plus 10 is 20. And 20 times something is 30. That's a little bit messier, but 10 plus 20 is 30. So we can keep adding 10 to get 40 and add another 10 to get 50. So the addition rule is a little bit more consistent. So we see that it's adding the same number all the way through, and this is an arithmetic sequence. Now the top of the next column, we see that this pattern is actually decreasing. So I might think of this as division or subtraction. Here I'm subtracting 80 or dividing by 2, which is the same thing as multiplying by 1/2. And then I would subtract 40, or I could take half of it again. So we're not going to use the subtraction. We're going to keep going with the multiplication, and half of 40 is 20. Half of 20 is going to be 10. So the rule here is that we're multiplying by 1/2. And this is a geometric sequence. This next sequence is going down as well, and it definitely doesn't look like division. I am subtracting 3 each time. So 57 minus 3, and then minus another 3 to extend this pattern. 57 minus 3 is 54. Minus another 3 would give me 51. So I could extend that pattern if I follow the rule. And since I'm subtracting the same number all the way through, this is an arithmetic sequence. Now to get from 1 to 3, I can multiply by 3, or I could add 2. And to get from 3 to 6, I could multiply by 2, but this doesn't seem to be working. So 3 plus 3 would give me 6, and 6 plus 4 would give me 10. And it looks like these numbers are increasing. So the next one I'm going to add is 5 to get 15, and then I'll add 6 to get 21. Now the rule here looks a little different. I'm adding, but I'm not adding the same number all the way through. I'm going to add one more than before. So if I added 4 before, then I would be adding 5. And this is neither arithmetic or geometric. Even though the rule includes addition, it's not arithmetic because we're not adding the same number all the way through. This pattern has a special name to it as well. And these are triangular numbers, which we'll see why they're named that in a moment. So to get from 400 to 200, I can subtract 200, or I could take half. To get from 200 to 100, I could subtract 100, or I could take half of that again. So the taking 1/2 and multiplying by 1/2 is a little bit more consistent. So our rule is multiplying by 1/2. So I'm going to take half of 100 to extend the pattern and get 50, and take half again to get the last term of 25. And since we're multiplying the same number all the way through, this is a geometric sequence. Now with an arithmetic sequence, we're going to have a common difference, and if the rule is adding 2, my common difference is 2. Geometric, you have a common ratio, and your common ratio in this case is going to be 2 because the rule is multiply by 2. If it's neither, we're going to skip that one, but arithmetic in this situation, we're going to have a common difference, and the difference between all of those terms is 10. Going back up the top, this geometric will have a common ratio of 1/2 because you're kind of dividing by 2, but dividing by 2 is the same thing as multiplying by 1/2. And to stay consistent, our other geometric was increasing and had a common ratio of 2. And this one is decreasing, so it can't have the same common ratio. So we have a common ratio of 1/2 instead. For this next arithmetic one, we have a common difference of 3. And if there's neither, we don't have a common number going through that at all. And this geometric one will also have a common ratio of 1/2. Notice the difference between a ratio of 1/2 and a ratio of 2.
When we're looking at a growing pattern, we want to kind of see where we start off at. So I kind of see this dot is still there in the next box or the next term. So I'm thinking that this dot is the same dot that is in this first box. So I'm thinking that these two are the same. And it's growing in the shape of a triangle. So it's kind of like I'm adding two more dots to that original dot. And I'm adding it in the shape of a triangle. So I'm kind of adding that diagonal onto the dot that I already have. So you start with one dot for term 1. So in term 1, you start with one dot for term 1, then you're going to add 2 to get to term 2. But we're adding them in a special way. We're adding them across that diagonal. At this point, 2 more dots are added as a diagonal, and we're trying to keep that triangular shape. So as a diagonal in the shape of a triangle, and that's for term 2. Now to get this next term, or term 3, we're going to start drawing what term 2 looks like. Now to get from term 2 to term 3, we're going to be adding 3 more. So we will add another diagonal, but with 3 dots to create term 3. So we are adding those 3 dots in the shape of a triangle, or adding another diagonal. Now to get from term 3 to 4, we're going to have to add 4 dots for that diagonal. So term 4, to get term 4, we're going to add 4. And we're going to add these 4 more dots as the diagonal of the triangle. So we're adding them in the shape of a diagonal. Now, you could have thought of the first dot differently, and you could have imagined adding a diagonal in the other direction, or in the opposite direction, or adding a base or a row on the bottom of that dot. So what I'm talking about is we could have had term 1 and we could have added another row below that and kept on adding rows. We could have added the diagonal as we did, or we could have added the diagonal on the other side, so on the left hand side, or we could have done the diagonal on the right hand side like we did. So it's kind of extending out to the right, extending out to the left, or extending down.
Which could be the rule for the following pattern? So when we're looking at this, the first one's saying that we can subtract 8 from the previous number. So for 132, or answer choice A, it says that we should subtract 8. But we want to try the methods for answer choice B, C, and D as well. So if I do 132 minus 8, I need to borrow 1 from the 3 to make that 12, and 12 take away 8 is 4, and we get 124, which is the next number. So A is still in the running. Choice B says that we should be adding 32 to the previous number. 2 plus 2 is 4, 3 plus 3 is 6, and 1 plus 0 is 1, and 164 is not the next number. So answer choice B does not give us the next number in that sequence. Answer choice C says that we should multiply the number by 2, and that gives us 264, which is not the next number in that sequence. So answer choice C does not give us a good rule. If we divide the previous number by 2, so 132 divided by 2, 2 goes into 13 6 times, and 6 times 2 is 12 with 1 left over, and bring down the other 2, and 2 goes into 12 6 times evenly with none left over. But the answer that we get is a 66, which is not the next number, so answer choice D does not work either. But we want to keep going to see if answer choice A keeps working. So 124 minus another 8 is going to give us 116, and that's the third term. So 132 to 124 to 116, those are the first 3 terms. If we subtract another 8, then we're going to get 108, which is the 4th term of that sequence. And if I do 108 minus another 8, we're going to end up with 100, which is the last term that's shown in this sequence. So subtracting 8 from the previous number is the best rule. This happens to be an arithmetic sequence as well. What are the next 3 numbers in the following sequence? So I want to know what the next 3 numbers are. I need to figure out the pattern first. So I could do 5 times 2 is 10, or I could do 5 plus 5 is 10, and then 10 plus 10 is 20, but 10 times 2 is 20 as well. So I'm going to keep going with the multiplying by 2 because that seems to be a little bit more consistent. So if I want the next 3 numbers, I like to draw those blanks out and then fill in those blanks. So once I read the question, I write what I'm supposed to be doing, and then I do it. And 80 times 2 is going to give us 160. So the next number is 160. 160 are not there for the first term in answer choices A and D. So I'm going to multiply 160 by 2 to get the second term for my answer, and I end up with 320. And 320 is the next term in answer choices B and C. And if I multiply it by 2 again, 320 by 2, if I kind of estimate that, I can figure out that 300 something times 2 is going to be about 600. And 320 times 2 ends up being exactly 640, or answer choice C. Look at the table. Which pattern has a common ratio of 3? So this is knowing your vocabulary and knowing that a ratio means that we're going to be multiplying by that number. So we're looking at the first term, which is 6 in each of those patterns, and I want to multiply by 3. And I know that 6 times 3 is equal to 18. And the only pattern that has term 2 equal to 18 is pattern 2. So let's continue with pattern 2 because that looks like my best bet. So if I multiply 18 by another 3, then I should get the third term in the pattern. And 18 times 3 ends up being 54. So the third term works with this rule as well, or this common ratio of 3. Multiplying by 54 by another 3 gives us 162, and we see that pattern 2 is the one that we want. Pattern 2 is answer choice C. Be careful, because sometimes you think that A should be 1, B should be 2, C should be 3, and D should be 4, but in this case, 2 ends up being answer choice C. So read the questions very carefully. What is the next term in the sequence? 1 is kind of like 1 over 1, so to kind of make these all look like fractions, we know that our numerator is going to be 1, and let's kind of figure out what the denominator pattern is going to be. I see that 1 times 3 is 3, and 3 times 3 is 9, so another 9 times 3 is 27, 27 times 3 is 81, so 81 times 3 is going to give us that denominator, and that ends up being 243. So 1 over 243, or answer choice C, is the correct answer. Look at the table. Which pattern can be extended by adding 2 to the previous number? So our rule here is adding 2. So if we are looking at the pattern 1, we're going to start with 6 and see if adding 2 works. So 6 plus 2 is 8, and the next number in this, it doesn't go 6 and then 8, it goes 6 and then 18. So pattern number 1 does not work when we're adding 2. Pattern number 2 starts with 5, and if we add 2, our next number should be 7. So 5 and then, 25? It should be 7. So pattern 2 doesn't work either. For pattern 3, we're going to start with 500, and then we're going to add 2, and we get 502. So 500 and then 502. So far, pattern number 3 works. Let's keep going. Plus 2 more gives us 504, which works again, and then plus 2 more, we get 506. So pattern 3 looks like this works. Let's double check to make sure that pattern 4 doesn't work either. 1000 plus 2 is 1002, and it goes from 1000 to 500. So we're not adding 2 for the pattern number 4. So pattern number 3 is C. Be careful because they're not in numerical order. It goes 4, 2, 3, 1. So pattern 3, or answer choice C, is correct. Now for number 2, based on the geometric pattern shown, what's the value of 4 to the 8th? And when we are looking at a geometric pattern, we need to remember that it has a common ratio. Common ratios and common differences are really important. So common ratio means that we're multiplying, and we should know that because when we see an exponent, we are repeatedly multiplying. So if I want 4 to the 8th, I'm going to set up the rest of this pattern. So 4 to the 4th, 5th, 6th, 7th, 4 to the 8th, and write what those are actually equal to. So I see that it's a common ratio because I'm multiplying by another 4 to get the next level or the next exponent. And I want to get all the way down to 4 to the 8th. So I'm going to make a little table and organize my work. A lot of math is just keeping everything organized in a logic manner. So 4 to the 4th is 256, and if we multiply that by another 4, we're going to end up with 4 to the 5th power. So multiplying 256 by 4, we get 1024, which is answer choice A. But answer choice A isn't actually correct because answer choice A is equal to 4 to the 5th power. If we multiply 1024, or 4 to the 5th, by another 4, we'd end up getting what 4 to the 6th power is equal to. So 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9, 4 times 0 is 0, and 4 times 1 is 4. So 4 to the 6th power is 4096, which is answer choice D. So answer choice A was equal to 4 to the 5th power, and answer choice D was equal to 4 to the 6th power. So we're going to have to keep going. If we multiply by another 4, we're going to get 4 to the 7th power. So 6 times 4 is 24, 4 times 9 is 36, plus 2 more is 38, carry the 3, and we get 16,384 is equal to 4 to the 7th power. So answer choice B is actually equal to 4 to the 7th power, and isn't correct either. We need to multiply by one more 4. 4 times 4 is 16, 4 times 8 is 32, plus 1 is 33, 4 times 3 is 12, plus 3 more is 15, 4 times 6 is 24, plus 1 is 25, 4 times 1 is 4, plus 2 is 6, and we get 65,536. And that is equal to 4 to the 8th power, or answer choice C is equal to 4 to the 8th power. Kale wrote the number pattern shown. If the pattern continues, what will Kale's 7th term be? The 7th term is very important. The first term, we have the second term is 2, the third term is 3, 7 is the 4th term, 11 is the 5th term. We want to figure out what the next term is, or the 6th one, so that we can figure out what the 7th term is. And a lot of times people will accidentally put the next term, or the 6th one in this case, instead of the 7th term, or the one it's asking for. So we do 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 4 is 11. So the next two terms we're going to add 5, then add 6. So 11 plus 5 is 16, and 16 plus 6 is 22. So the answer is D, or 22, for the 7th term. For question number 4, it's asking which pattern below has a common ratio of 1/3. So a common ratio, you need to remember that that has to do with multiplication, and we're going to be multiplying, in this case, by 1/3. So when we see 162 times 1/3, we need to put them both in fractional form, and 162 times 1 is 162, and 1 times 3 is 3. And that's basically the same thing as saying 162 divided by 3. So we normally use multiplication to say the rule, but when we actually divide by 3, we get that the next term should be 54. So 162 and then 54 are the first two terms for A. So we're going to keep on dividing by 3, which is the same thing as taking 1/3 of something. And 54 divided by 3 is going to end up giving us 18, with none left over. So 18 is the next term, and here we could do this in your head, and 18 divided by 3 is 6, and 6 divided by 3 is 2. So A does have a common ratio of 1/3. But we want to check out all the other patterns too. So B starts with 108. So we're going to divide by 3, and 3 goes into 10 3 times with 1 left over, and 3 goes into 18 6 times with none left over. So our first term is 108. When we divide by 3, we get 36. So sometimes we divide by 3, and the first two terms, that works for all of them. So when we divide again, we get 12 though. And we see that the next number is 18, not 12. So B is not correct. For answer choice C, we start with 105, and we divide by 3, and 3 goes into 10 3 times with 1 left over. Bring down the 5, and 3 goes into 15 5 times with none left over. So we see that we have 105 and then 35 after dividing by 3. And then to get from 35 to 32, you actually subtract 3. So we're not dividing by 3 in this case. We're multiplying by 1/3. So C is not a good sequence either. And if we look at D, we're going to start with 120 and see if dividing by 3 would give me 90. So 3 goes into 12 4 times with none left over, and 3 goes into 0 times with none left over. So the next number should be 40, not 90, if it's following this pattern. So A is the only one with a common ratio of 1/3. Write down any questions that you have on this topic and bring them to class. You're now done with your notes.